Let us look at this problem. Varun lives in a small city with only one bank that provides the facilities of borrowing and lending at an interest rate of 6%. So first thing is that the interest rate is 6% for both lending and borrowing. Varun has a job that ensures an income of rupees 1,04,000 this year and 1,06,000 next year. Okay. His utility function is simple, just a Cobb-Douglas function, and assume prices, they don't change over the period. So in the first part, you're being asked to find out his optimal consumption bundle, C0 star, C1 star, and does he lend or borrow this period? Does he lend or borrow this period? So let us have a look at this question, which says what? So you have equation of the intertemporal budget line. Intertemporal budget line is, we've already done in our earlier recording about this thing. So it is what? C0 plus C1 upon 1 plus R equals to M0 plus M1 upon 1 plus R, right? So it means what? C0 plus C1 upon 1 plus R, and then you have 1,04,000 plus 1,06,000 upon 1.06. 1.06 is what you have. And when you will just solve this up, that is M0 plus M1 upon 1 plus R, you will be getting 2,04,000. This is right. So supposedly, I mean, if you are not going to consume anything tomorrow and you're going to consume everything today, then this is the maximum consumption which you can have. So I'm just finding out this guy. This is C0 here, this is C1 here, and this is this point where you're consuming everything in this period. So this is what? M0 plus M1 upon 1 plus R, and once you plug these values beta, which is 1,04,000 plus 1,06,000 upon 1.06, you will have 2,04,000, right? Now if you want to find out, that is, if you're going to consume everything tomorrow, you're not going to consume anything today, then what is the maximum consumption you can have? So in that case, you can write C1 as what? M1 plus you will be saving everything, that is M0 minus C0 into 1 plus R. That is what you will be doing. M1 is what beta? 1,06,000, right? You are not consuming anything today, so you're consuming everything tomorrow. So it is 1,04,000 minus 0. Why? Because you're not consuming anything today, into 1 plus 0.06. So I think when you will solve this up, you will be getting 2,16,000. Something, I guess it is going to be 240, I guess 240, right? Okay, this point. So this point is what beta? This is the maximum consumption which you can have next period when you are not consuming anything today, right? So it is what? And you can put C0 to be 0. That is like this, and when you will just like this becomes your budget constraint. So you have everything with you. You have this horizontal intercept, you have the vertical intercept, and you also have this guy, this thing, endowment. which is what? 1,04,000 and 1,06,000. This I'll call as point E, which is the point of endowment. You're starting from this point, beta. You're starting from this point. Now you have the utility function. What is your utility function telling you? You have to maximize U is equal to C0 C1 subject to C0 plus C1 upon 1 plus R plus M0 plus M1 upon 1 plus R. So you can just set up the Lagrange. So you have C0 C1 plus lambda M0 plus M1 upon 1 plus R minus C0 minus C1 upon 1 plus R. You can just write like this. So you can set up the Lagrange and you can just find out three partial derivatives, one with respect to C0, other with respect to C1, other with respect to lambda. So del L by del C0 is C1 minus lambda equals to 0. Del L by del C1 is C0 minus C1 is here also, lambda upon 1 plus R equals to 0. And del L by del lambda is M0 plus M1 upon 1 plus R minus C0 minus C1 upon 1 plus R. This is 1, this is 2, this is 3. So what I can do? I can divide first by second. I can divide first by second and I will be having C1 upon C0 equals to lambda upon 1 plus R. So this will be just 1 plus R beta. So C1 would be equal to 1 plus R C0. I can substitute in third. So what will I get? M0 plus M1 upon 1 plus R minus C0 minus C1 upon 1 plus R, right? So it is what? M0 plus M1 upon 1 plus R minus C0 minus, in place of C1 I can write 1 plus R C0 upon 1 plus R equals to 0. So this is 1 plus R gone. So you have what? M0 plus M1 upon 1 plus R is equal to 2 C0. And C0 is equal to half of M0 plus M1 upon 1 plus R. Beta, but you have already calculated M0 plus M1 upon 1 plus R. You know that? Yeah. That is 2,04,000. Right? That is 2,04,000. So you have what? Half of 2,04,000 is 1,02,000. This is what my C0 star is. And C1 star is what beta? 1 plus R C0 star. So it is 1.06 1,02,000. So it is going to be, once you will calculate it, I think you will be getting 108,120. 108,120. This is what you will be getting, C0 star, C1 star. So you have 1,02,000 and 108,210. So basically what you have is this. So you are consuming little less today and you're consuming little more tomorrow. So C0 star is less than what your income is today, and C1 star is little more than what you have tomorrow. So you are consuming at, let's say, point A. So at point A, if you guys can look at it carefully, your C0 star is less than M0. You're consuming less today. It means what? You are a lender. So you are a lender in this particular period. Right, beta? You are a lender in this particular period. Now suppose the bank decides to give an interest rate of 8% per annum on deposits. So if he tries to be a lender, he'll be given a 8% interest, and bank is going to charge 10% per annum if he is going to be a borrower. So if you draw Varun's intertemporal budget constraint again and find out his consumption, C0 star and C1 star, right? C0 star and C1 star. So let me just draw the case. Well, you have this, you have C1 here, you have C0 here, fair enough. Let me just mark M1, that is 1,04,000, and let me just mark M0 is 1,04,000 and this guy is 1,06,000, right? So at this particular point, these are nothing, I'm just pointing the point. These are nothing, I mean, you can just forget about them. Okay, so this was my endowment point. Fair enough. Okay, now let us say if he wants to be a lender. Well, if he wants to be a lender, so let me just find out first of all that point where he is not consuming anything today and if he is going to consume everything tomorrow, right? If he is not consuming anything today and if he is consuming everything tomorrow. So I want to find out the intercept on the y-axis first. Well, this is going to be my consumption in time period 1 is going to be my income, savings from the previous period, plus interest on those savings. That's what it is. I can write this as M1 plus 1 plus R, M0 minus C0. But C0 is equal to 0 because I just want to find out first of all that point as an intercept on the y-axis. So this is just nothing, M1 plus 1 plus R, M0. What is your M1? M1 is next period consumption, that is 1,06,000, plus now the lending interest rate is 0.8. So 1 plus 0.08 is going to be 1.08, and M0 is what, beta? 1,04,000. So once you solve this, you will be getting 2,18,320 here. So let us say this becomes my point, and if I am going to consume everything tomorrow and nothing today, then this is the maximum consumption I can have. Fair enough? Okay. Now let me just find out my, in case if he decides to be a lender. If he decides to be a lender, then he will be maximizing C0 C1 plus lambda M1 plus M2 upon 1 plus R minus C1 minus C2 upon 1 plus R. So I'm not repeating this thing again because you're going to get the same answer. Your C0 star is going to be half of m naught plus m1 upon 1 plus r, and c1 star is 1 plus r c naught star. This you have done already in part 1. Okay. Now let me just write that beta. So this is going to be what? 1,04,000 m naught. M1 is 1,06,000 whole upon 1 plus 0.08. So I'm sure when you will just solve this, you'll be getting this guy 101,074. This is going to be my C naught star. And C1 star will come out to be 1 plus R, that is 1.08 into C naught star. That will come out to be 109,160. Right, beta? So now if you look at it, so C naught star is 101,074. So it's somewhat little lesser than this point. Somewhere here. Let me say this is point B. So if he is going to be a lender only. Well, and this also seems to be right, beta. If you look at C naught star, your consumption in C naught star is less than M naught, then yes, you can be a lender. I mean, you can be means this Varun can be a lender. So he can be a lender. He can be a lender. Yes, he can be a lender. Okay. The question is still not complete yet. So don't go anywhere. Okay. Now, supposedly if he decides to be a borrower, so I need the intercept on the horizontal axis. If he decides to be a borrower, I need an intercept on the horizontal axis. So what will that be? Was my budget is C naught plus C1 upon 1 plus R is equal to M naught plus M1 upon 1 plus R. Beta, I am not consuming anything today. So I want an intercept on the horizontal axis. So for that, I'm not consuming anything today. So basically my C naught intercept on the horizontal axis will be this. What was M naught? 1,04,000. What is M1? 1,06,000. And what is the borrowing rate? 10%. So it is 1 plus 0.1. Right, beta? So it is 1.1. So it is 200,364. And C naught star is going to be half of this guy M naught plus M1 upon 1 plus R, which you have just calculated. So that is going to be, I'll just draw the budget constraint. Just wait for a while, beta. C1 star is going to be 1 plus R, that is 1.1 now. So that is going to be something like this. Now you just think about it. You have this guy. So this is 200,364, and first of all, this is going to be little steeper. Why it is going to be steeper? Why it is going to be steeper, beta? It is going to be steeper because it is going to be steeper because the slope here is 10%. In the lending case, the slope was 8%. This point is your 200,364. right? This is the lending case. So the slope is 1.08. This one, borrowing case, slope is 1.1. But you also look at it. Don't you think that your C naught is greater than M naught? Is this? Oh, sorry, C naught star. What is your C naught star? 100,182, right? And M naught is what? 104,000. So C naught star, C naught star is less than M naught. I'm so sorry, it is less than M naught. When you are consuming less than your income, how can you be a borrower? You won't be a borrower. You're consuming less than your income, na?